In this video, we are going to see about the application of mathematical induction in Domino's effect. There is a slight difference between the recursion and induction. Induction and recursions are intimately related. The recursion is nothing but a strategy for writing programs that compute in a divide and conquer fashion. You solve a large problem by breaking it up into smaller problems of the same kind. That's what the recursion is. Whereas the induction is, it is again a mathematical strategy for proving statements about integers, more generally about sets that can be ordered in some fairly general ways. For example, if say sum to n terms of 0, 0, that may be our base case, and sum of the n terms in an arithmetic progression will be the sum of the n minus 1 term plus the nth term. So we are adding adding all the previous one with using the recursive method step by step, and then adding the last stage. Or we can even find the next stage Sn plus 1, which is Sn plus n plus 1. The Domino's effect assumes equally spaced dominoes where it is spacing between the spacing between the dominoes is less than the length of each domino. Now we argue that this, if we disturb the first one, definitely the remaining will fall. The argument is, suppose if the first domino falls because we are pushing it, the second one will fall because the length of the first one is less than the distance between these two. So definitely it will knock the first domino. The same case, the first domino will knock the second one because again the length is smaller. So like that it continues. So how do we argue this using the principle of mathematical induction? We know that the principle of mathematical induction is we have to assume that the result P of n is true. And if we are trying to prove that for each case 0, 1, 2, etc. k, we cannot complete the whole thing if k is quite large. So we need different steps, like we take the initial case as P of n, and then we have to prove the base case, and also we need the induction step using the induction hypothesis where we assume P of k is true, and then using P of k we will be proving P of k plus 1. This is what is mathematical induction. So let us use this mathematical induction for the Domino's effect. Let us prove this by mathematical induction. So the initial condition, that is the statement, the claim P of n, the domino n falls, is assumed. And the base case is true because when n is equal to 0, there is no domino, so that is true. For the inductive case, we have to assume the inductive hypothesis that the statement is true when n is equal to k, that is the k dominoes fall. We have to prove that the k plus 1th domino also falls. So if the k plus 1th domino is attached, and definitely that k plus 1th domino will fall because the distance between the k plus 1th domino and the remaining, the previous one, is less than the length of the domino. So it will definitely knock it over and it will fall. So P of k plus 1 holds, and this is our inductive argument. So this argument is compact and it works even for infinite number of dominoes. So we say that it is a mathematical induction. Now let's use the principle of induction in this problem using stamps for money. The theorem is, for all n greater than or equal to 8, P of n holds where P of n is such that n can be made using 3-cent and 5-cent stamps. That is, using 5-cent and 3-cent stamps, we can buy any possible combinations. So the base case, let us take two different cases, P of 8 and P of 9. When 8, we can use 3 cents and 5 cents. If it is 9, then we may use 3 cents. Sometimes, instead of just one, we may use more than one as base case. And in this case, we are using two, P of 8 as well as P of 9 as base cases. So for the inductive case, let us assume that n is greater than or equal to 9. We have to prove that for n plus 1 or k plus 1. Let us take two different cases. Case 1, let us assume that it has a 5-cent stamp. Then if it has a 5-cent stamp, in order to have n plus 1, remove that 5-cent stamp and then add 2 3 cents. 2 3 cents will be 6. So instead of 5 cents, it will add 2 3 cents. So it will have 6 cents. So altogether it will be n plus 1. If it doesn't have a 5 cent, then take 3 out and add 2 5 cents. So 3 cents will be 9. Instead of 9, you are adding 2 5 cents, which is 10. So the total will be n plus 1. And this is what we have to prove. You can also practice this exercise. Prove by induction for n greater than or equal to 23, you can have any combination of 7 and 5. That is 7x plus 5y equal to n. So this video helped us to understand how to use this mathematical induction principle to explain the dominoes effect. So thank you for watching this video, and thank you for supporting this video, and thank you for listening, and thank you for your patience. Thank you.